Welcome to our YouTube channel. In this video we are going to do design of substation gantry structure in Eurocode with the STAAD.Pro. This is a stage 2. In this we are going to see load combinations and we are going to apply that into our model, structural model which is developed in STAAD.Pro. You can see on the screen an Excel sheet having the table of load combinations. This is as per table 4.2.5 and 4.2.8 of European Standard EN 50341 part 1 for reliability level 2. So this in the right hand side the picture of table which is showing the national annexure load combinations. We are going to consider this highlighted load combination alone. Extreme wind we are having 3 directions 0, 45 and 90 degree. For minimum temperature we are having one combination. For extreme ice plus 1 also we are having the same. And for extreme ice and moderate wind, that is 3A load combinations, we are having 0, 45 and 90 degree 3 direction. For high wind plus nominal ice, that is 3B, we are having 3 cases according to the wind direction 0, 45 and 90. Construction and maintenance we are having one case. For accidental we are having one case. The primary load table also slightly modified so that the load icon is inserted here. The load icon D and DI are the dead load without ice and with ice respectively. And similarly for wire tensions there are two major things we are considering, that is 0 degree deviation and 30 degree deviation of conductors. Even in that 0 degree and 30 degree deviation we are having subdivided of wire tension in 0 degree Celsius, minus 20 degree Celsius and T minimum, that is minus 40 degree Celsius. So similar like the same thing for 30 degree deviation also. Extreme wind cases we are mentioning WE, and based upon the directions we are having 3 cases 0, 45 and 90 degree. Similar like for high wind and moderate wind we are mentioning as WH and WM and respective to the direction 0, 45 and 90 degree. For short circuit force also we are having 2 cases SCF 0 and SCF 30, which are depends upon mainly the deviation of the conductors. And finally T minimum, MIN, we are having a minimum temperature for structural minimum temperature loads. So accordingly we are doing these combinations with the factor mentioned in the table showing in the right hand side picture. So generally STAAD used to have an input editor where we can directly copy paste this Excel value of load combinations and the load factor which we are going to define now. So that could be a very easy for us instead of doing that model itself, model window page itself, adding the load combinations by clicking the tab. It is going to take more time and even it is going to confuse us. So what we are going to do is we are going to give a input in input editor of the STAAD.Pro model which we had already developed. So for that STAAD.Pro model which are developed, you can refer our previous video how to create the model substation gantry structure model in STAAD.Pro. We had well explained in our previous video. The link for the video is provided in the description. So now we are going to calculate likewise. So for input to STAAD.Pro, we need to mention the load combinations like this fashion: load space COM, that is a combination, and we have to mention the combination number. After that we can give any description by providing space. So we are making the formula like this: load space COMP space, the load value which we are having here as a 201 lowercase number, and the load combination definition we are having here. So likewise we are making the formula, so we can just copy paste. So we had define the load combination description here. Now we need to define the load factor and load combination factors. So the load combination and the load factors we need to define like this for STAAD input. So first number we have to mention the load case. Second one is the combination factor. So here in this we are having a D in load number 1 and its combination factor is 1. Similar like for wind, extreme wind case for 0 degree, we are at 9th case, the factor is 1.2. So likewise we need to mention all the load combination. So for that what we can do is we can enter here in the table. So our first case is load case number 1. So if you see first 4 cases we are having the dead load without ice. So we can just copy and paste up to this 4 case. And for load combination for the dead load for all the load cases it is 1. So we can directly type here 1 for all the load cases. Similar like for load case of dead load for ice consideration, whereas start from 205 to 211 we need to consider DI, that is dead load with ice, which is a load number 2. So for that we can have it load number 2 here from 205 to 211, and factor also same 1 for that. So next one is for 202 and 213 and 212 we can consider same as dead load 1. So now we had given the dead load, but in case of extreme ice case you can see here DI should be multiplied with 2.5 ice. So we can directly have this formula because this formula will vary according to the reliability level. So we can directly enter this formula here 2.5. So here that dead load with ice we need to consider 2.5 times. So likewise we had defined the dead load and its combination factors. Next one is we need to do for wind. So next we are going to define the wind load. So we know that it is a extreme wind case 0 degree. So for the extreme wind case we need to consider the load combination load as load case as 9, which is for 0 degree Celsius, 0 degree direction. So next one is 45 degree. We need to consider the next case. Here we have 0 degree, 45 degree and 90 degree directions for extreme cases as 9, 10, 11. So we are adding this 9, 10, 11 here because these load combinations are having 3 directional extreme wind alone. Similar like for load combination for wind, the load factor is we need to copy and paste this. So we defined the load, wind load, and the factor remains same for all the directions. So similar like if you go and check for minimum temperature there is no wind. For extreme ice plus snow case also there is no wind. And the next is extreme ice plus moderate wind we are having wind, and high wind plus normal ice we are having wind. So for this 206 to 211 we are having wind cases. So we can just copy and paste this for 206 and 209. But only thing that wind case we need to change, because in this 206 to 208 we are having moderate wind. So moderate wind cases are start from 15. So select this 15 and edit for other direction also. So 15, 16, 17 is a 0 degree, 0 degree and 45 degree and 90 degree cases. Similar like for high wind case, we need to select the load number from 12, 13 and 14. So now we had defined the wind load cases. Now next load is wire tension we need to define. So here WT 0 degree 0 Celsius we are going to consider. So for that the load case we need to consider number 3 and its load factor is 1. So we can directly enter here 1. So this is applicable for all the 3 cases. As you can see here, WT 0 degree Celsius we need to consider. So next one is accordingly the wind load calculation. For load case 206 also we need to do it. So for load case 6, 7 and 8 also the same thing. Similar like for 9, 10, 11 also same kind of tension. You can see here 0 degree Celsius wire tension we need to consider for extreme ice plus moderate wind and for high wind plus normal ice. So we had derived load combination factor for all the 3 type of extreme or high wind or moderate wind cases. And now we need to define for minimum temperature. So in minimum temperature you can see the T minimum of structure we need to consider, that is load case number 20. Again here the factor we need to consider is 1. Next one is normal tension we need to consider for minimum temperature, that is we are having here load case 5 for minimum temperature, that is minus 40 degrees Celsius. So here you can see in the image, which is a table, load combination table as per the national annexure. So for extreme wind case we need to consider the conductor tension for 0 degree Celsius, and for minimum temperature we need to consider the T minimum, that is minus 40 degree, which we had defined here in the wind and ice load combination, that is environmental load parameters we had defined. And for extreme ice and extreme ice nominal wind, high wind plus nominal ice case we need to consider 0 degree Celsius of wire tension only. Only for construction and maintenance we need to consider minus 20 degree Celsius wire tension. So in this case the minimum temperature we need to consider the minus 40 degree. For load case 204 we need to consider wire tension for minus 40 degree. So it is 5th case. Similar like this factor is 1. For 205 ice load combination we need to consider wire tension as per 0 degree Celsius only. So the same 3 we can copy paste here, and the factor for the wire tension is 1. So next one we need to define for constructional loads, that is a 212. For that you can see we need to get minus 20 degree Celsius wire tension. So here is the load combination load number, the primary load number is 4. Again the factor we are considering here is 1.5. So in this table image also you can see it is 1.5 mentioned. So finally, for short circuit forces, we need to consider SEF force for 0 degree deviation, which is 18, is a load number, and for this case the load combination factor is 1, as here mentioned as a security and accidental loads. In case number 5, the gamma A value is 1. So finally we had arrived the load combination factor. So we can now have a gap between this, so that we can add this load combination factor here. So this load combination factor, we need to have a formula like this. So this adding this, copy paste this, and so this is a load combination factor we had added to suit for input editor to STAAD.Pro. So next we are just cut and paste here, so that if you are doing copy paste, automatically this load number and load combinations used to come here. So then we can cut and paste to the respective load combination. So likewise, we had defined the load combinations description and its load number and its load combination partial factors. So these are the things we need to copy paste to the STAAD input editor. Similar like we need to do for deviation angle also. So we had calculated now for the wires spanning parallel, that means no angle of deviations. So let we copy paste the same, and we can edit here for spanning, incline, with angle of deviation. So now this conductor wire tension alone is going to change. Instead of 3, it should be 6, because the 6, 7, 8 are the conductor with deviation. So all this remain 6, and this 5 become 8. Same 6, and here this 3 again become 6. Similarly, this 4 become 7, that is for minus 20 degrees Celsius. Also this 12 short circuit force to be 13. Sorry, it should be 19. That is short circuit force with deviation of conductor. So these are the load case for conductor with deviation. Here this load case number we need to change it, as it is end with 213, we can add it here 221. Similar like we need to prepare this load combinations like which we had done for no angle or of deviation of conductors. Now we have added the commands, load combination commands for conductor spanning inclined, that is with angle of deviation also. So these are without deviations, and these combinations are with deviations. So we can also add star conductor or wire tension without deviation, wire tension with deviation. Now we can open our STAAD model, go to utilities, click a command file. So you can come to last line here. After temperature load, press enter and just copy paste your load combination which we defined here and paste here. Just Control C in Excel and Control V here in input editor. So now all the load combination in the Excel sheet are pasted here. Now you can save and close this input editor, and you can also check our load calculation view. You need to click here combination, click this view load, so you can check all the load combination which we had defined. Also you can see in this load and definition tab, so in this the blue color which are mentioned as a C, it means it is a load combination. So this is all about how to add the load combination in STAAD model for substation gantry structure. Thank you. Look description for more related videos. Subscribe to this channel for more updates. Thank you.